This video will introduce ForceFit, which is an educational design exploration tool that makes use of graphic statics. Graphic statics is a historic analysis method which assesses equilibrium and determines internal forces within structures. To complete analysis using graphic statics, two diagrams need to be drawn. Firstly, the form diagram, which represents the geometry of a given problem, and secondly, the force diagram, which shows all the internal forces within that structure. Note that these two diagrams are reciprocal, meaning that they're inherently linked, and that changes to one automatically results to changes in the other, and vice versa. ForceFit is built in Grasshopper, which is a plugin for CAD software Rhino, and as you can see here, the interface is split between the two programs, with all the inputs and the computation happening on the Grasshopper side, which is on the right, and the visual outputs are on the left, which is the Rhino window. Within Grasshopper, the user can set the base geometry, which includes parameters such as the width and height of each brace module, the number of stories, or the total wind load. The output, so the force diagram, is shown on the left. The program is split into three key sections. The first option is to manipulate the graphic statics form diagram. Workflow 1 allows the user to adjust the base geometry, with the forces in the force diagram updating in real time. After each iteration, the axial force of members can be read by measuring the length of the corresponding vector on the force diagram. The second option, Workflow 2, allows the user to manipulate the graphic statics force diagram as opposed to the form diagram. In this process, the geometry diagram is back calculated from the user-adjusted force diagram in a reverse application of graphic statics. For example, if I decide that the internal forces in this member here are too high, I can simply reduce them by moving this node in the force diagram downwards. This has immediate effect on the geometrical form, which adjusts to maintain equilibrium. The third option is to run an optimization function to reduce the deflection of total material volume. After I've explored a form, for example this one here, I can choose to run an optimization to identify which changes I should make to my initial concept to make it more efficient. Within the program, I can choose between volume and deflection targets. For example, I choose to optimize for volume. I select the nodes on the force diagram that I'm okay with adjusting, and open the Galapagos optimization module. This is Grasshopper's inbuilt evolutionary algorithm. I can then run the optimization and observe how the frame is adjusting in response. You can see that the volume is reducing from the initial value on the right here. When I'm done, I can stop the optimization and pick one of the many other reduced volume frame layouts from this box here. Thank you for watching this short introduction, and I hope you found it interesting.